First of all, thank you to Adam, to Gail and to Eva and for the rest of the team for organizing this great event. I really look forward to the rest of the agenda and all the exciting sessions ahead. My name is Lasse Jamt and I'm heading up the Renewables and Utilities division in Kongsberg Digital. We are an industrial software company that works with heavy asset industry on digital transformation so they can reimagine how they work. The future energy system is characterized by a large share of renewable intermittent energy, from wind, from solar, from other renewable resources. And as we all know, this is driven by climate change, politics, and lately also energy security issues. Secondly, increasing electrification of transport, our manufacturing processes, but also an increase in electricity consumption from new energy-intensive industries such as battery manufacturing or data centers. Third, the future energy system is a system that needs to stay resilient due to more extreme weather. We've all seen and we've all read about the heat waves going on, the wildfires and the floods. And in cases of emergency, security of supply is even more paramount. Finally, a fourth characteristic of the future energy system is obviously the step change improvement in technology that is impacting storage technology, smart grid technology as a whole, but also, of course, digital technologies. As with the panel earlier this morning, I would like to spend some more time talking about grid and what role the grid plays in the future energy system. In many ways, the grid is the logistics of the energy transition and an extremely vital part for making it happen. However, we must also acknowledge and try to address the fact that the future energy system and its characteristics represent challenges for the grid and the grid operators. The grid is by nature a patchwork and was necessarily not built for this increasing complexity. The grid operators are facing a lot of issues: voltage deviation issues, capacity problems, and bottlenecks in the grid, causing expensive curtailments of production, etc. Increased pressures on new connection, and just basically an increased cost of outages as well, given the fact that we've now electrified even more. There's, in general, a high expectations of cost and quality. Grid operators themselves, they want to be a facilitator of the energy transition and even an accelerator. But grid operators always need to strike a balance between the security of supply and the pace. The solution to the challenges are, I guess, as always, a combination of things. First and foremost, we need to make the most out of the grid that we already have. The grid needs to be instrumented more in order to maintain security of supply, while at the same time increase the pressure and increase the utilization and strain on the existing grid. We need to run it a bit harder, but in order to do that, we need to know more and have more insights about its limits. We need more calculated risk in order to do this. Secondly, there's no doubt we need to build new grids, a lot of grids, and introduce new smart grid components into our grids. The majority of the grid investments in the coming years will of course be hardware. And we believe data-driven and decision-making and investment plans that are built on data and insights from the variety of work processes and the variety of legacy systems within the grid operators need to come together to make sure we get the most out of that investment. Thirdly, we believe that the grid operators need to engage more with the end users, the producers. It's a system that requires a lot more proactiveness in terms of flexibility behind the meter, but also new connections on different conditions. Some of the challenges posed by the energy system will require this increased interaction between load and the grid, and flexibility behind the meter especially, and how to make use of that flexibility in the day-to-day operations of our grids. A commonality for the different parts of the solution is that digital and new technology will be an enabler and an enhancer of the tools in the toolbox. Just as electrification goes hand in hand with the decarbonization of our economy, digitalization will play a central role in driving the change in an optimal way. Digitalization is critical for handling long-term change-driven uncertainty and unlocking innovation. That is why we have developed Cognitwin, an industrial work surface, where you can unify your data, your people, and your knowledge in one easy-to-use and access location. As grid companies move from traditional systems to smart and complex grids, and as grid operation moves from reactive to proactive, digital twins can provide insights and forecasts to identify bottlenecks, to simulate different grid scenarios, and of course to optimize grid investments. By combining our electrical condition modeling with the technical and mechanical condition, contextualizing data from different parts of your system that describes one asset together brings you really closer to that full picture. Moving seamlessly from analyzing historical data to viewing what's going on in the real time, to looking at what's forecasted to be ahead of you, that's really interesting work that a digital twin can do for you. The use of artificial intelligence and advanced physics-based models will enhance the value of the traditional DSO and DNO tools available. With time and with flexibility behind the meter, again, when that becomes more relevant, a more modern system solution will enable grid companies to do more. We believe the digital twin will be one of the key enabling technologies for the energy transition. And I would like to end today with a video. And despite what this video shows, we encourage you to use your twin for something smart. Say hello to Cognitwin.
Here we go. Oh! 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 You all right? I'm okay. Huh. I thought that might happen, by the way. Oh.
That was hilarious. Absolutely hilarious. I didn't expect that Lasse to come at the end. That was really good. Because you know when you sometimes watch his videos and they're all, because that was beautifully put together. And then suddenly you have that. That was fantastic. Really good. That's a great representation of a digital twin, I think. So well done on that, whoever thought of that. So Lasse, it was a brilliant presentation, really concise, but really well thought out. And obviously you covered some of the points in your opening panel as well. With some of the things you mentioned in your presentation. Very keen to sort of understand a couple of things from you, because we all talk about the value of data and how important data is, data in and data out, and data quality. How big a barrier is data at the moment?
No, Adam, that's actually a question we get a lot from our potential customers and the grid operators. And to be honest, I would be lying if I said it was no problem at all or no barrier. It obviously is. I mean, in our solution, we combine and contextualize data from GIS systems, from SCADA systems, from sensoring systems, from AMI infrastructure. And the degree of data quality in those systems, they vary a lot. Some of these systems are quintessential legacy systems. So so it is a challenge. But however, we see that actually one of the first sort of pieces of value that we realize through implementation of a digital twin is actually increasing data quality and getting a very clear picture about where you are as a grid operator when it comes to that, because you sort of see it very visual, and I mean that's actually, yeah, as I said, the first value that is realized. But it is something that needs to be not overlooked. It needs work, and And there's the old phrase with shit in, shit out still holds up.
We've
And
heard that a few times.
yeah, and I think we need to be take that into consideration, of course. But I mean, the first step and the first value is actually starting working with it, and a twin could actually be a good way of doing that.
Yeah, because I like what you mentioned in the panel earlier, because everyone's has this obsession with the word digital twin, and I think people have got to put that to one side and actually think, right, that's great, but you sort of mentioned about how you've got to focus on what solution it's going to provide. So, and I think that's a really good point, because everyone bandies that around, and it does get a little bit overused, I think, when it comes to that. And I think people underestimate the need for it. What about, can I ask you though, Lasse, data standards, because you talk about data and data in and data out and the application of data, but what about data standards? Because how is that actually helping the innovation progress on technologies like this?
Yeah, no, I think standards is something that we, as a provider of the tools we love it because it makes our life easier when it comes to creating code that is robust and can be implemented fast. So we obviously love it, and I think it also is helping innovation progress, and it's increasing the interoperability between systems. So you could actually take an example. We have a couple of Norwegian DSOs that we're working with who can actually do an export from a couple of their systems and feed it into our system without any manual interference, and it spins up a working and converging grid model of their entire grid from regional grid level and down to individual meter points. And that could not be done that fast if it weren't for some agreed standards that actually, at least I know that the Norwegian grid operators are working on. And there are similar standards out there developing. So for those who are interested in the SIM standard and grid modeling, please contact, because we are working quite a lot with that, because it obviously improves implementation time and cuts down time to value, to be honest.
I think it's a very good point on that as well, because we've got a few sessions on standardization. It does differ country per country. I realize the DSO framework is largely completely different to what we have set up in the UK, especially when you speak to some of the providers there, and I think there's quite a few of them compared to what we have over here. So it's interesting to when you see different viewpoints from different countries in Europe. Finally, because we see, and I see, a lot of collaboration between people and companies that you don't expect, and some of that maybe can come down to vendors or technology providers. So how do you see this progressing? Because I've seen a lot of that, even within other energy parts, let's say from oil and gas. It's happening a lot now within utilities and power. What's sort of your take on vendor collaboration? And I think James mentioned on the opening panel that we can't rely on one company to get us to these goals, so we're going to have to collaborate. So what's sort of your take on it, Lasse?
I think cooperation and collaboration between vendors in the grid area is increasing. However, from my understanding and knowing other industries as well, from a lower starting point than perhaps some of the others. So it's getting better. I think it's very important. I think the future energy system would be also characterized by an ecosystem of vendors doing things together for the good of their customers. But I think it's paraphrasing a different saying. Different industries get the vendors they deserve, and I think the customers and the industry as such needs to start asking for collaboration when they go out and buy new software or new systems. So I think there's a role to play for the grid operators as well, of course, in driving that collaboration, basically forcing vendors to collaborate as well if they don't want to.
I think that's a fantastic point. I think it's a brilliant presentation, Lasse. We're very grateful to once again be working with Kongsberg on this event. Now, Kongsberg are the official digital twin partner. Please go and see them as well on the virtual booths. They've got some wonderful information there, and contact Lasse as well for any information regarding the CogniTwin. But Lasse, thank you for joining us, and thank you for doing the opening presentation. And we speak again very soon.
My pleasure, Adam, and enjoy the rest of the sessions.
Thanks, Lasse. Fantastic words from Lasse Jamt, the VP of Renewables and Utilities for Kongsberg Digital, a really, really strong partner we have for the event. So we now have a very quick break. We're going to be back in about 5 minutes, where I will be doing a Q&A with the CEO of Hitachi for UK and Ireland, Ian Funnell, which I'm very excited about. So if you can join me back again in about 5 minutes.